So let's try this one. In this case, we will try to say that 1 over x times x plus 1 could, in a good day, be broken up as something over x plus something over x plus 1. If we're lucky, maybe it could be broken up like that. Let's see. Let's not be afraid and try it. This would be x plus 1 times a, b times x. This should be true for all values of x, more or less. So I'm free to choose any values that I want. I would say, what if x was equal to 0? If x was equal to 0, that statement should still be true. The premise is that if you've broken up this fraction with x's and whatnot, and you did it correctly, it should be true for all x's. Otherwise, you couldn't say that they're equal. And there's more to that. There's a deeper story, but maybe it's not the right place and time to explain that deeper side of the story. I'll let you figure out if you see anything that needs more thinking about. For most of you, this will be good for now. Okay, replace, if x is equal to 0, this would be 1 is equal to a times 1 plus b times 0. That goes away, leaving you with the inevitable conclusion that a must be equal to 1. Try it again. If x equals negative 1, that would give you 1 is equal to a times negative 1 plus 1 plus b times negative 1. Canceling this, leaving you with the conclusion that 1 must be equal to negative b, or b is equal to negative 1. What does that tell you? That tells you that their original problem, which was 1 over x times x plus 1, can be written as a over x, that would mean 1 over x, and a b over x plus 1. It's easy to verify that. If you get a common denominator on those and add them together, you should of course get that. That would be an easy way to verify that you've done it correctly. Anyways, here's the beauty of it. If you were to integrate this side with respect to x, that would be the same thing as integrating this with respect to x and integrating this with respect to x. And the beauty, of course, is that this is so much easier to integrate than that. I could do this with 2 fingers. Look, I could do this with 2 fingers. ln of x plus negative 1 times ln of x plus 1 plus a constant. Told you. See why they pay me? Way too easy. Partial fraction decomposition. Alright, I should warn you, there are sometimes a couple things could go wrong, and so maybe we should take a couple examples that show you some of the possible things that could make this technique just a little bit more interesting.